There are 5 primary processes of InfoPoints: your data import, preprocessing, modeling and analysis interchangeably, and then getting into your collaborative outputs. We're a global company. We got our start in Hamamatsu, Japan, and then transitioned into the States. We have over 35 years of CAD expertise across the company, which gives us the capability to leverage that expertise for 3D data translation, interoperability, and other solutions that we offer off the shelf, but also we have open opportunities for development projects and efforts. The viewer file gives users the capability to generate a method that can go to any Windows machine and be able to view any of the information that would have been captured in the primary InfoPoints project. The first one came out a little too much detail in the segmentation to host remote web meetings directly inside of the point cloud, all inside of a virtual reality meeting as though you were on site. So I'm here to talk about our product, InfoPoints, and what it means for us to be enhancing the point cloud utilization and leveraging various technologies in a streamlined workflow, including virtual reality and 3D design. So a little bit about myself. My name is Nate Soulje. I'm an application support specialist at Elysium, Inc. This is going on 5 years since I started at the company. I focus on our point cloud solution, InfoPoints, here at Elysium, Inc. But I also support all of our other technologies that I'm going to touch on a little bit as an introduction of Elysium Inc. itself. I graduated with my Bachelor's of Science in Nuclear Engineering to start with back in 2015 before moving on into mechanical engineering with a focus on finite element analysis. So a little bit about Elysium. We're a global company. We got our start in Hamamatsu, Japan, and then transitioned into the States and going into a global company, reaching into Europe as well. We have over 35 years of CAD expertise across the company, which gives us the capability to leverage that expertise for 3D data translation, interoperability, and other solutions that we offer off the shelf, but also we have open opportunities for development projects and efforts. So a little bit about InfoPoints. That's what we're all here to talk about, is the point cloud solutions and none of the other boring stuff, right? So InfoPoints is a large-scale point handling tool that's here to facilitate the entire workflow of point clouds, from the consumption of the data from your scanner all the way out through a variety of outputs. So this is going to be used in various industries, including construction, shipbuilding, manufacturing, and more. So just taking a quick look at the 3D scanner classifications, we've had that discussion a little bit, so I'm not going to go into detail. But mostly what I want to point out is just where InfoPoints falls in line with all the other scanner classifications. So typically we see our customers going for the indoor-outdoor scanning, starting at 10 meters all the way out to thousands of meters, depending on what your scanner is able to capture, and then also going into your mobile mapping systems and being able to support that information. The concept of InfoPoints, as I've mentioned before, is to facilitate the entire workflow of point cloud. So from the consumption of that data from your scanner all the way out to your various collaborative outputs, whereas this came about because software solutions, years ago started off as being very segmented and very specialized for what our customers needed. So you would have one solution that did your registration, you would have one solution that would do your modeling, you would have a third solution that did your collision detection. So we wanted to bring all of that into one desktop solution. There are 5 primary processes of InfoPoints: your data import, preprocessing, modeling and analysis interchangeably, and then getting into your collaborative outputs, being able to consume that data beyond the solution. So talking about data import, there's a lot of software solutions out there that, again, they specialize on a specific format of data. What we wanted to do is be able to be scanner-agnostic, be able to consume a variety of point cloud data from a variety of scanners on the market. So being able to take your tripod scanners, your mobile mapping systems, your handheld scanners, etc., bring them all into one solution. And not only that, but be able to support multitudes of formats in one project. So for example, if you have a Faro tripod scan that you use to capture a manufacturing facility, and then you have a dot product handheld scanner that captures a very specific piece of equipment, With InfoPoints, you can pull all that together and register it as a single cohesive project. So from there, we're going to get into some pre-processing. That's your registration, that's your denoise, that's preparing the point cloud data for usability throughout your process. So for automatic markerless registration, that's the capability of the software, and this is InfoPoints in real time, going into the point cloud and being able to look at it and look at the different features of that point cloud and be able to determine how it all fits together so that if we have our various point cloud scans, we'll be able to bring those into a cohesive project. This can be done with and without markers in the field today. We also offer automatic noise reduction or automatic denoising within our solution. So this is one of the categories that we look at, that's overlapping noise. When you're talking about tripod scanners in particular, that technology, you go out and you take multiple scans within a facility, such as going into this host space. If we wanted to use a tripod scan, I would need several different locations within this space, and in doing so, I'm going to capture similar pieces of the environment with multiple scans. So for example, we've got the bar top right here on the first level behind everybody. If I come through here and I take 3 scans in front of the stage, I'm going to get segments of that bar top 3 times. I don't need triplicate information to represent that same information. So we're going to take it into InfoPoints. We can denoise it down to the bare essentials, which makes it lighter and easier to use. Another example is kinetic noise. So you're in a manufacturing facility, or if you're on a vessel, for example, none of those places shut down for anybody. So you're going to have to go in there and you're going to have to scan while it's in motion. InfoPoints is able to recognize when that occurs and be able to hide the information and get the information out of the way that might represent a worker passing through that environment or a piece of equipment passing through that active scan, and be able to, again, clean it up, make it lighter, make it more efficient to use. Up next, various forms of modeling within the point cloud. So being able to take that point cloud, turn it into a usable mesh, or even a 3D solid model as required for your downstream workflows. We also offer support for unstructured point cloud formats. So this is the part of the presentation where I ask a quick question. How many people know the difference between unstructured and structured point clouds? I got 1. Anybody? 2, 3? Okay, so there's a few people. Really quick, for everybody who doesn't know the difference, an unstructured point cloud, bare bones, is going to be a list of points and color values in a text file, for example. So that's your XYZ values, your unstructured E57s, etc. If you were to look at it and open it up on your machine, it is just a list of values. Structured point cloud data takes it a step further and adds a relational matrix to each point, so that when your machine is looking at that point cloud, or so that when the file is generated, there's a distinct relationship, point-to-point relationship, that tells the software this point is connected to that point, it's connected to that point, etc. And that relationship is very important for doing automatic processes in software solutions. So with InfoPoints, we have the ability to leverage these unstructured point cloud formats and be able to turn those into solid models and other usable outputs. So talking about mesh creation, that's the ability for the user to come into the environment, segment the point cloud to isolate the specific areas that they're interested in, and turn it into a usable mesh model. So from there, we can also talk about pipe modeling. So InfoPoints has the ability to extract these pipe cylindrical elements from the point cloud, and you can then leverage them into different connective pieces, such as elbows, flanges, etc., all within this solution before you even get to your CAD and BIM solutions. With InfoPoints, we can also use it for some design work. So if you're able to come into the environment and InfoPoints can recognize 2 endpoints for a pipe, we can also have InfoPoints give us a layout based on knowledge of that point cloud and other entities that exist in the point cloud solution, or that might have been extracted, and use that to determine a new layout in advance, again, of those BIM solutions. From there, for visualization and to get as much out of the point cloud as we can, we also support texturing these different surfaces. So any planar surfaces or any piped surfaces, we can take the point cloud, texture these surfaces with the point cloud, and be able to visualize them either on the desktop solution or even in a VR headset. Up next is equipment modeling. So with this user, what they've done is they're going to come into the environment and they're going to use the extracted planes from the environment first and foremost to grab the boundaries of this space. So they can go in and the user can select any plane that they need to represent in this case, the walls and then the floor in succession of this space. InfoPoints will then connect all those together using the information from the point cloud to get that accurate space that can then be used for either drawing creation or even so to create these electrical panels for other pieces of equipment within the environment, and then create those 2D layouts and drawings based on that information. Up next, similarly, steel structure modeling. So the ability to take that point cloud data and turn it into steel structures that also included in the solution is a library of different standard elements that are used throughout the industries today. So if you have a standard element that you want to use and just plug it in, you can pick it from the library and build it against the point cloud solution and use that for verification. Next is duct modeling. Similar to pipes and steel structures, we want the ability to represent these duct elements. With InfoPoints, we give you those tools in order to recognize those straight duct elements, connect them together into usable segments in the environment, and then you can also, moving on into other functions of InfoPoints, valve modeling with our pipes. So in this case, just like with steel structures, pipes and valves have the ability to apply standard elements from libraries within InfoPoints right into this information. And then all of that standard information can be exported to BIM solutions using the IFC format where it's supported. We also have a Revit plugin that I'm going to be discussing later that can take all this rich information directly into Revit and use it for your future BIM modeling. Up next, different forms of analysis with InfoPoints. So the ability to come in and analyze either measurements within the environment, doing real-time interference checking or collision detection, as well as being able to do comparisons against your point cloud and your CAD models. So doing the measurements, it used to be when these solutions were first introduced, you would have to take point-to-point measurements, which often led to some slight human error in that measurement. So we're talking about a couple of inches here or there, but that can be really important depending on what you're measuring. Well, with InfoPoints, we have the ability to extract these elements and then take the measurements against the extracted elements. So for example, with that first measurement, we've got center line to center line of those pipes for a precise measurement of that clearance, as well as from the surface of that overhead pipe down to the floor, again, getting a precise measurement based on those extracted features. Up next, real-time interference checking or collision detection. This is going to be very powerful when you need to come in and do facility management or layout planning and being able to determine how you're going to get a new piece of equipment into the environment or vice versa, pulling an old piece of equipment out and knowing, do I need to bring it in piecewise? Do I need to move existing pieces of equipment out of the way? With InfoPoints, we have the ability to analyze that in detail and recognize in advance where those collisions are occurring and be able to address them accordingly before having to go on site. So here's another example where a user has the ability to take a mesh model that was generated from the point cloud. Maybe in this case, the user doesn't have the precise model already available that they can use to just pull in and do these analyses. We got to use what we have. So in this case, the user can take the point cloud, segment it down into the pieces that they need. So in this case, an old piece of equipment, a pump, and then turn that into a mesh that can then be used for interactive collision detection, where the user can now move that piece of equipment wherever they need in the environment, or also do path-driven collision detection, where the user can come in, predefine a path that they expect to remove that piece of equipment, and verify that it is actually going to be feasible to do so in its current condition. Now, I want to talk a little bit about an NSRP project that we actually just finished earlier this year. So NSRP, for anybody that isn't aware, is the National Shipbuilding Research Program, and we were awarded a project to work on in conjunction with Huntington Ingalls Newport News Shipbuilding, which is a shipyard out of Newport News, Virginia. The idea of the project was to be able to do validation of your as-built environments against design data that Newport News already has on hand and be able to use that in order to do comparison and reporting of the current environment against what was originally designed. The project goals, as I just described, primarily CAD versus point cloud overlay. Be able to consume the point cloud, be able to consume the CAD, automatically overlay those together, and then do automatic validation of those two environments and determine any differences that occurred and be able to report them efficiently so that they can either be planned for or addressed as required. We also had a secondary goal for automatic recognition and extraction of label plates within the environment. So on these vessels for Newport News Shipbuilding, everything is labeled from the pumps to the bulkheads and more. And being able to recognize that information and where it exists in the environment is very powerful for being able to know what they're going to be working on and what may need to be replaced. So for data import for this project, Newport News Shipbuilding set up a proof of concept environment in a warehouse, and they came through, scanned the environment, and also produced a JT model for the use in our process. So in this particular case, we have the ability to consume the scan data, consume the JT models, and overlay them together as the start of this process. From there, the first phase of the project was to generate a method for InfoPoints to automatically segment the point cloud and pair it to different components within that JT assembly. So in this particular case, we can see that there was two phases to that segmentation process. The first one came out a little too much detail in the segmentation. So with this, for example, the heat exchange here on top of the pump, we can see that each one of the fins has been segmented as individual point cloud pieces, when in reality, it's part of a much bigger heat exchange unit. So with now, with that completed, we can recognize those larger pieces all together, and then being able to take that and automatically pair it off against the CAD components for validation. So what the analysis looks like, in this case, the user has already completed the analysis, which generates a report that's right here on the right-hand side of any differences or similarities that occurred in that analysis. So we can see here, as the user clicks through, each assembly piece has its own listed area on this table that I can click through and analyze individually, or I can analyze that entire environment as a whole. By clicking on the individual pieces and going in, we can see very precisely where any of those deviations occurred, as well as being able to identify anything that may need to be addressed. So just to go ahead and give the color coordination, red is anything that exists in the model but does not exist in the point cloud. So it's something that theoretically was removed from the environment after it was designed. Blue is anything that's been added to the environment. So we came through, we designed our JT model, created the JT model, captured the point cloud environment, and after capturing the point cloud environment, we identified something new compared to what was designed. From there, anything that's in yellow is something that is similar but has a significant deviation that should be analyzed by the user. Maybe it's a bulkhead that's got some separation to it, it's got some deviation of that particular bulkhead in a specific area that the user can then go through and analyze. Or otherwise, we've got potentially it was built and it was just offset by a couple of centimeters, whatever the case may be. And then otherwise, it's going to be colorized in gray to indicate that it is a matching component within this environment. Up next, we need a way to be able to consume this outside of the solution. So not everybody's going to be able to walk around and carry a nice heavy, 10-pound laptop that can go into this point cloud solution, process it, and also review any of the results. They need to be able to consume that report maybe on a tablet or a smartphone and be able to do that on site in an efficient manner. So in this case, what we did is we generate an HTML report that can then be consumed by a web browser and viewed in a web browser that still captures all the necessary information about where in the environment the deviation occurred, as well as the specific locations in that environment for those deviations. Up next, InfoPoints and how it generates collaborative outputs. So first and foremost, getting down to basics. Orthographic images. They're still powerful tools today for a variety of workflows, even if it's just a simple handoff to say, hey boss, here is a cable tray that exists in the environment. It's going to get in the way of a new piece of pipe that I want to lay out at this particular Z direction and at this coordinate. An orthographic image is a powerful tool that still speaks 1,000 words. So being able to do that, come in here, put a grid on that image and be able to take measurements off of it is still a powerful tool. Up next, fly-through videos and being able to give those to project collaborators or customers and be able to say, here's your environment, this is what it looks like today, and you can get that full and rich experience without having to go on site. So here, the user can go through and capture different viewpoints just based on where the camera is in that environment. InfoPoints will then piece that together as a fly-through path and then can generate the video. Up next, exporting a viewer file. So again, an easy way of consuming the data, but also sharing that with project collaborators. The viewer file gives users the capability to generate a method that can go to any Windows machine. So it's going to specifically be laptop and desktops in this particular case, and be able to view any of the information that would have been captured in the primary InfoPoints project. However, with the viewer file, it's much more limited functionality, but it is completely licensed and software independent. Once that viewer file has been generated, I can hand it off to anybody, and then that person, again with a Windows machine, can open that viewer file, they can take their own measurements, they can make their own comments, and they can experience that environment the exact same way as the original engineer. External linking directly into the point cloud, making the point cloud kind of the master environment that you can use for keeping an eye on what's occurring in the environment. So in this case, maintenance schedules, websites, etc., being able to pull all that into the environment and keep track of it all within the point cloud, making the point cloud your central reference point for any of that information. So I said it a little bit earlier, we were going to talk about the InfoPoints Revit plugin, but for our InfoPoints Revit option, the idea behind it is to generate the models using the point cloud within InfoPoints. And then once those models have been generated, we can use a Revit file out of InfoPoints that can then be consumed by Autodesk Revit and turned into native Revit capabilities. So being able to change your walls, being able to take all this rich information that you've just spent your time designing in InfoPoints, carry that over into Revit, and then use it as native Revit data. So in this case, once the files get transferred over, I can then use those pipes as native Revit pipes. Again, being able to preserve any of the library components that I would have used. So in this particular case, I've got a piece of pipe that I want to add insulation to. I can do that using Revit just like any other pipe that I designed there. If I want to, I can change the wall any which way I need to and be able to use that information just as I would have in the Revit solution. So for InfoPoints for VR, so just like with the desktop solution, we have the ability to experience this environment in virtual reality using a couple of different headsets, specifically Oculus or HTC Vive. So being able to use these headsets, come into the environment, we can experience that environment, we can add notes to the environment directly from the headset. We also have the ability to support coming in and taking scenes in the environment that will relate back into the desktop solution. And most importantly, in my opinion, the ability to host remote web meetings directly inside of the point cloud, being able to collaborate with those users all inside of a virtual reality meeting as though you were on site. So if anybody has any questions, I don't want to take up the time of the next presenter. If anyone has any questions, I'll be here both today and tomorrow. Please feel free to reach out to me. This is my direct contact information at Elysium Inc. Please feel free to reach out with any questions that you have. I'll be more than happy to answer.